Hey guys, in today's video we're going to be setting up pressure advance and input shaping on the CR10S Pro V2 running Clipper on a 4.2.7 board. Guys, if you're new to the channel, consider subscribing, turn on your notification bell, and leave me some comments. I love reading the comments and do my best to respond to you guys as soon as I see them. All right, let's just jump right into it. This is a part of a header plug that I had ordered on Amazon, and I'll link in the video description all of these parts. Now, this was a full length header pin. It was about this long, and what I did is I cut out the section I needed along with its pins. This one has 8 pins, but this can be purchased like this without having to cut anything down. And this piece of wire is about 23 inches long, and this is a standard female JST connector. It's a 6-pin. And then the other section is the ADXL 345 on a little mount that I made for our Creality sheet. So this slips right on that little protrusion that comes out of the front or the back. And then on this side I got a male JST. This cable is 32 inches long. And then to neatly hold it, I printed up this part, designed it in on shape, and conveniently the CR10S Pro V2, the housing, has a little square cutout, and I'll show you where that is in a minute. And the way this is going to go is the header pin side slides into this opening here. Oops. And then the JST side sits in this little pocket, just like that. I'm going to put a little dab of hot glue in here to hold it so it doesn't move out of there. And then it gets this little cover. And then this whole thing will snap into that hole. It's supposed to snap into that hole. We'll see if it'll actually snap in. But another thing that you can do is either a little dab of hot glue on this side, or maybe some real thin double stick tape would also work. Or you could do a little bit of hot glue and a little bit of silicone. The hot glue will hold it till the silicone dries, and then the silicone will take over from there. So let me show you guys where that hole is. All right, so it's going to go through here. This little guy's going to snap in here on the side. And then the plug is going to plug right in here into the Raspberry Pi. Now, I'll put up a diagram as well as include our little Clipper cheat sheet that we made up. And the way that this wiring goes, the 3.3 volt goes on the 9th pin from the bottom set of rows with the orientation of the header plug facing up. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9. And the good thing is that this little dock for the CM4 is marked with a little yellow box. See if I can get you in close so you can see. So you guys see that little yellow mark right there? That yellow mark is where the 3.3 volt of the header pin has to go. So it's going to go just like this. Just like that. So I made up these little clips in Onshape, and I'll make them available in the video description if you guys want to use them. All right, let's jump over to Clipper and check to make sure that we're getting a response from the ADXL 345. In the Clipper session for the printer, you want to enter the following into the console. So let's jump over here to our document. So I have a section that I added here. So this is everything having to do with the accelerometer. It starts on page 30. And on page 31, you have the following info. So you're going to grab this section over here where it talks about the accelerometer. So right here, accelerometer query. You can copy this, or you can do a search. You can click over here and type in accelerometer. All right, so here's accelerometer query, and then click it, and then you want to send it. And you're gonna get values like this. If you don't get these values, check the connection and make sure that you properly hooked it up. So this confirms that we're getting communication between the Raspberry Pi and the accelerometer. So let's jump back over to the printer, close it up, and I'll show you guys how to mount it to the print head. What I did here is I redesigned the fan bracket that I made for the MicroSwiss NG to include the two mounting points for the ADXL 345. That way it can easily be mounted and removed when not in use. One thing that's very important is when you're gonna do the resonance test, that the printer be set in whatever area that it's gonna perform work. You don't want this thing on a test bench doing the resonance testing because it's gonna differ when you put it in the actual permanent spot where the printer is gonna reside. So move the printer over to where it's gonna be printing at, and then run your resonance test. All right, so let me home the printer first. All right, so let's jump back over to Clipper, and I'm going to show you what the next steps need to be. All right, now that we're home, let's go back to our document. And we want to grab this first line. So shaper, calibrate, axis equals X. Copy, back to Clipper, paste it in the console, and we're going to send it. Let me set up the camera over by the printer so you can see what the printer is going to do. Once the test is complete, you want to save underscore config. Just copy that, paste it, send it, and it's going to restart the printer. We can confirm to make sure that the settings are there. Click on the wrench icon, double click printer.cfg, scroll down to the save underscore config section, and here you got input shaper Y, input shaper X. Now we haven't done the Y yet, so it just updated this. This is the old data from the previous one, so I'm just gonna grab this just to save it, just to be sure. Alright, I'm going to delete this value because this is an old value. Okay, let's go back to our document. Next thing we want to grab is shaper calibrate axis equals Y. Back to our console, we're going to save and close. So let's jump back over to the printer and we'll move the accelerometer from the print head to the bed. All right, one thing you want to make sure that you do is to unplug the accelerometer. That way, in case you touch any of the metal components on top while you're unscrewing it, you don't damage it. And then we're going to move it to the front of the Creality. So once we take it off of the print head, it gets screwed onto this little mount. And then I'm going to try to get this thing as close to the middle as possible. And we can use this little caution sign that's on the CR10S Pro V2 right there towards the bottom of the screen. You can see the little triangle to help us align the accelerometer mount in the center of the Creality build plate. All right, first thing I got to do is home the printer. And the rattling noise that you're hearing right now is the latch on this piece of furniture that the CR10S Pro V2 is currently on top of. That thing is rattling like crazy. Grab this save underscore config, copy it, and we're going to save it. So it's telling us here the recommended for Y is 38.6. So we'll confirm to make sure that all of our settings are correct. Let's head back over to the wrench icon, open printer.cfg, and there we go. All right, so you remember our old values. So this was the shaper frequency Y. This is for one of the Ender 3 V2s, 37.4. This one's 38.6. All right, so that's all we need here. Now that we got our resonance values in, let's figure out what our pressure advance needs to be. On page 33, you want to download the test square, load it into your slicer, and change the following. You want to set the speed at 100 millimeters a second, walls set it to 2, ink fill 0%, layer height 75% of the nozzle diameter. In my case, I'm using a 0.4 millimeter nozzle, so I'm going to be printing at 0.3 millimeter layer height. So let's jump over to the slicer, verify the settings, quality 0.3, walls 2, ink fill 0, speed 100. Now let's jump over to Clipper. So let's start by going back to our document, and we want to enter the following in the console. So this first one here, set velocity limit square corner velocity, acceleration equals 500. So let's copy this, paste it into the console, send it. Let's grab the next one. Now with these next two commands, it depends on what system you're running. So you got a choice. If you're running Bowden, you would select this top one, which ends in 0.020. If you're running a direct drive like I am, you're gonna grab this second one that ends in 0.005. And if you get an error, check the spacing. I'm gonna have to fix it in this document here. But it looks like the problem might be over here, maybe. Yeah, there it is. Okay. All right, let's head over to the slicer. We'll load up the model. All right, once we got our values set, let's go ahead and slice this and send it off to Clipper. All right, I stopped it early because it was already starting to show issues. So let's take it over to the bench and we'll analyze it. So what you want to look for is the area where the corner is still a corner without it over extruding around the edge or under extruding. So you can see this side here is, if you look at it from this angle, you can see that there's less material around the turn here, and over here there's too much material. So you want to find the happy medium. And each one of these sides, each one of these edges are going to be slightly different. So I'm just going to eyeball this, and I'm going to just mark it. So I'm going to say, okay, over here, this looks good to me. Come over to the next one. The next one is like way up here. Let's go to the other one. This one's way down here. And then finally the last one. Okay, next thing I want to do is I'm going to take down some measurements. And you want to measure from the bottom up. Make sure to zero out your caliper. So I'm starting over here. This looks like about 20. I think this one was the oddball. So put 20. Let's get the next one. This one is 24.6. Say 24.65. $18.3. And 18.75. Over here real quick and double check this one measurement. Yes, that's right. All right, let's add those up. All right, I got a total of 81.7. And what I'm going going to do is I'm going to take an average. So 20.425. Alright, so now this 20.425 gets multiplied by 0.005 because we did our test based on direct drive. So that gives us a value of 0.10 pressure advance. So this is my pressure advance right here. And this is going to be under the extruder section in the printer.cfg. You're going to add this line. Pressure underscore advanced equals, and then 0.102. That's it. All right, let's go put it into Clipper. Okay, so let's head over to the machine, wrench icon, printer.cfg, and let's look for the extruder section right here. I'm going to change this from 0 to 0.102. Save and restart. Now that it's restarted, let's jump over to Cura. We'll load up a production part that I was printing previously before doing this upgrade. And I used to print this part at 65 millimeters a second. Let me show you. Okay, so there's the speed, 65 millimeters a second. And let's slice it so you can see how long it used to take me to print this. All right, so 11 hours. That means that I'm limited to about 2 of these per day, printing at 65 millimeters a second. And that's as fast as I could go without introducing a bunch of ringing into the print. So now we got input shaping and pressure advance installed and configured. Let's increase the speed to 100 millimeters a second. Reslice it and see what kind of time savings we get. All right, so just over 8 hours. So we got time savings of 3 hours, and so that means that I can increase my production by 1 more of these per day. Let's go ahead and load this up into Clipper, and we'll print it. All right, guys, first part has come off the printer after switching to Clipper. So let's pull it off of here and we'll check it out. So let's take it over to the bench and then we'll look at it. Yeah, it looks good. I don't have any ringing or anything. It looks clean on the inside. Get this brim off of here. Shine some light in here so you guys can see on the inside of here. Yeah, super clean. Let's check our threads. Alright guys, so that's a wrap for this video. Guys, if you're new to the channel, consider subscribing, turn on your notification bell, and leave me some comments. I love reading the comments and do my best to get back to you guys as soon as I see them. I got a tiny little bit of ringing over here. Alright guys, till the next one. Take care.